Today, ladies and gentlemen, I'll be adding sections to my text parser, which is exciting because once I've done that, I can parse a full ini file. So let's make it happen. Let me start by laying out a test case here, show you what I'm aiming for. This is the ini text I originally presented back in part 1, and as you can see, I have two sections, editor and terminal, and each section starts with a header. The header contains two tokens my tokenizer doesn't recognize yet, so let's start there. First, I add the two new token types. Both are single characters, so tokenizing them is the same as tokenizing an assignment operator. Just change the character and the token type. Change the character and the token type. Now, I just spent a whole episode on cleaning up my code and already I'm muddying it up again. Least I can do is extract this into a function. Let's see. I need to pass the tokens array, the errors array, the index, and the token type, of course. This should be token type. Note that I'm changing the index here, so I have to pass it by pointer. And that means that I have to dereference it everywhere. I need brackets here or the operator precedence does exactly what I don't want. Alright, now let's use it. Well, that looks nice and all, but I accidentally got rid of the error handling. Here you can see that I need to break when something goes wrong. That break is still in the function actually. Let's return false instead to signal an error. True if everything is well. And that's a boolean, of course. And now I can check for errors and break. Same for the new tokens. Start header. End header. That should be it. So let's run it. Here are the tokens for the first header, nice. Then I have two assignments. And then I should have my second header. Nice. I suspect the parser will be a bit more work. So far my parse tree is just a list of assignments, hardly a tree at all. But sections will add another level to the tree because an ini file is now a list of sections, each of which has a name, and a list of assignments, and that's how I want it to look. Now the question is, how do I represent a section in memory? The name is not a problem, there's a text token for that, but how will I store the list of assignments? I could just create a static array, right, with size max assignments. That's possible, but to fill it, I want to wrap it in the array structure that I wrote last part. So maybe I should just put an assignment array in the section. Although I'm not sure how I would initialize that. And I think I have a better idea anyway. I reserve a pool of assignments here. Just because I need multiple lists of assignments doesn't mean I need multiple memory pools. I'll reserve memory for sections and memory for assignments. Both start out empty. First thing I see is a header, so I allocate a section and store the name. Then I have an assignment, so I allocate memory in the pool of assignments and store the key and value. Then I let the section point to that assignment. There's now one assignment in the section. I allocate the next assignment, and now there's two assignments in the section. Then I get to a new section, so I allocate it from the pool of sections. For the next assignment, I allocate space in the same pool of assignments as before, and I will let the new section point to this assignment. This way I can use one pool of assignments for multiple lists. So I add a pointer to the first assignment, and I keep track of the number of assignments. A section header is pretty straightforward to parse. It's a square bracket, followed by a name, followed by a square bracket. I only need to keep the name around, so I'll just skip the brackets. First, I check if I have a start header token, because that indicates the start of a header. Alright, I can just skip that first token. Then I get to the name, but first I check if the token type is correct. If it isn't, well, it isn't text, so it can't be the start of an assignment, but it could be the start of a section header. So I won't skip it, I'll just let the parser try again with this token, but one level higher. And that reminds me, the value of the assignment can now also be the start of a section header, so we shouldn't skip the token here either. Downside is that you now might get 2 errors on the same token, but that's better than missing a section header. Right, so the token is text. Store the name in a temporary variable for now, until I know that the entire header is valid. Next token. That should be end header. I'll need to add that error type. This is a nice place for it. And no, let's not sort it alphabetically. If I have the right token, I'll skip it. And then I can create a section. Sections are no different than tokens and assignments and entries, meaning I need a section array. I'll initialize it in main. I set max sections to 3 in case you're wondering. Doesn't really matter that much. Pass it to parse. Add a parameter. And now I can allocate a section here. And set the name. But current section can't actually be local to this block because I need to add assignments to the current section. So let's declare current section here and I'll initialize it by allocating a new section. That means that I always start with a default section before I pass anything. It doesn't even have a name and that's fine. Now to add an assignment to the current section, all I have to do is increase the number of assignments in the section. It's that simple. However, I also want to know if maybe this is the first assignment in the section. So if the current section doesn't have a first assignment yet, then this is its first. I think that should work. I have 3 sections, so that is good. The first one has all 0 values, but that's okay, it's the default section, so it doesn't have a name and I'm also not adding anything to it. I know it looks like a sentinel, but I got rid of those, it's just a regular section. The other sections have the correct number of assignments, and the assignments are still here in one static array. Good. If all I have is assignments, then the memorizer just needs to copy the key and the value to the string buffer, and then add an entry with the index of the key and the index of the value. Sections are pretty similar actually. First I copy the name of the section to the string buffer, then for the following assignment I add the index of that name to the entry. The next assignment will have the same section index because it belongs to the same section. If I encounter another section, I first copy the name to the string buffer, and after that each assignment will use the index of that name. That means that I need to pass the sections to the memorizer. I don't need to pass the assignments anymore because the assignments are contained within the sections. Change the parameter. And the next thing I want to do is iterate over the sections, which requires a section iterator. Same as the other iterators. Okay, so I initialize the iterator and now I can create a for loop. Now the whole assignment part needs to be in that for loop because every section has a list of assignments. I'll get to that, but first I'm going to copy the section name to the string buffer. This is just like copying the key, but with the current section name. But now I don't check for a buffer overflow. I can copy that check as well, but fits in buffer takes an assignment and I don't have an assignment, I have a section. So let's rename this to assignment fits in buffer. And then also create a section fits in buffer, which takes a section, then calculates the length of the name, and then does the check. So this should now be section fits in buffer. Splendid. Next problem is that handle buffer full also wants an assignment. That's because a memorize error stores an assignment, but in this case, that's not good enough. I guess the easiest thing to do is to just add a section. If the buffer is full because of a section, assignment will be null. If it's full because of an assignment, section will be null. Crude, but effective. Update handle buffer full. Update the call here. And the call here. Almost there. The assignment iterator should start at the first assignment in the section and end, well, at the last assignment in the section. But that's nice, right? The iterator doesn't need to go over the entire array, it can start anywhere and end anywhere. Now all that's left is storing the section in the entry. I store the index before I copy the section name, and then I can set the entry here. Wait, I still need to add that to the struct. I can run it now, but I'm pretty sure that will go wrong. Yeah, that's wrong. Section is fine, but it's that first default section and it doesn't have a name, so this won't work. I think I should just test for that here. If there's no name, I want to add an empty string to the buffer, because then I can use that as the name of the default section. Now the string buffer is already filled with 0, so all I have to do is move 1 forward, and this will put an empty string at the start of the buffer. Of course, I need to record the section index first, which means I have to declare section index before the if. If that's a bit hard to follow, let me show you in the debugger. See, the first character in the string buffer is a null character. Then at index 1, it's the name of the first section, and the second section is at index 35. If I look at the entries, you see 2 sections with index 1 and a section with index 35. I can also show you what happens if I add an assignment to the default section. If I run it now, the section of the first entry is at index 0, and that's an empty string. With that empty string in place, the get function doesn't even have to worry about the default section. I will need to pass the section name as an extra parameter, but if I want something from the default section, I just pass an empty string. Get needs to accept the section name I'm looking for. Then for the current entry, I get the section name from the buffer. And then I check that both the section and the key match before I return the value. That should do it. Font is monospace, good. Color not found because it's not in the section terminal, good. And immortality is forever, also good. Well, that's it. My text parser has all the features I was planning for it, but I'm not quite done yet, because next time I want to see if I can be a bit smarter about the sizes of those arrays. It's no good having to recompile every time you need a new ini file. So, subscribe if you want to stay up to date. A big thank you to my Patreon supporters. You keep me going. See you next time, and remember, coding, it's fun.